we have this 3 cross 3 matrix A, and in this matrix A on diagonal we have 1, and the elements which are below the diagonal they are 0. That means it is upper triangular matrix, right? In case of upper triangular matrix, the elements below the principal diagonal they are 0, and there are two unknowns A and B, right? The other three entries they are A and B. If for some n belonging to this natural number n, matrix A raised to n is this matrix where on diagonal we have 1 1 1, and the elements above the diagonal they are these three elements, and elements below the diagonal they are 0. Then we have to find the value of n plus A plus B. So basically here we have to calculate this matrix A raised to n in terms of n, and then by comparing the corresponding elements we need to get the value of n, A and B. Now in this problem there is one important concept, that because for matrix A the element below the principal diagonal they are 0, and on diagonal we have 1. So we can write this matrix A as identity matrix plus some other matrix B, right? And if I break this matrix A as I plus B, then clearly you can see that matrix B will be I means 1 1 on 1 1 1 on diagonal. So the other matrix B, this will be nothing but will have 0 on diagonal. The elements below the principal diagonal that will be also 0, and you will get only 3 elements above the diagonal which are non-zero elements. And then if you calculate B square and higher power of that matrix, then after a point you will get null matrix, because we are writing matrix A as I plus B. So this 1 1 1 on diagonal that will be taken care by this identity matrix. So here you will get A and B, and these elements are still 0. So this is our matrix B. And if I have to calculate A raised to n, then we can calculate I plus B raised to n. And we can expand that using binomial theorem, because I and B, these two are commutative matrix, right? Now, if this is matrix B, then let us try to calculate B square. For finding B square, we can multiply this matrix B with B, right? B square means matrix B into B. So here B square will get again 0 0 0 on diagonal. The three elements below the diagonal they are also 0, and then we have A and B. Now let us see what we are getting for B square, right? So because this is one important concept, there are few PYQ where you will get these type of matrices. Upper triangular matrix where elements below the principal diagonal they are 0, and we have 1 on diagonal. Now here if you calculate B square, first row first column that will give us 0, first row second column 0, first row third column, so that will give us 0, then AB, and then again 0. Second row first column 0, second row second column will be 0, second row third column that is still 0, third row is completely 0, so these three elements will become 0. So this is our matrix B square, and you can verify on your own that if you calculate B cube, that means B square into B, so that will give you null matrix, right? If I calculate B cube, this will be null matrix, and the moment B cube is null matrix, any large power, any higher power of that, B raised to 4, B raised to 5, B raised to 6, all of these matrices, they will be null matrix only. So that means now if I have to calculate A raised to n, we can use the binomial theorem for that one. A raised to n, this we can write as I plus B raised to n, because I and B, these two are commutative matrices. So therefore we can use binomial expansion. So this will become I raised to n, nc1 into B, and then nc2 means n into n minus 1 by 2, this multiplied by B square. And because PQ is null matrix, so after that B raised to 4, B raised to 5, all of them are null matrices only, right? So this is our matrix A raised to n. A raised to n, this will be I plus n into B plus n into B square. And the given matrix A raised to n, let me write that matrix here, and then we can compare the corresponding elements. So for A raised to n, this was given as A raised to n, right? This was our matrix A raised to n. We had 1 on diagonal, and then we have 48, 2, 1, 6, 0, and then 96. So now let us try equating the corresponding elements. That will give us equation in A, B, and N. And by solving those equations, we can get the value of A, B, and N. So A raised to N is this matrix, and A raised to N is I plus N into B, N minus 1 by 2 into B square. So if I equate the corresponding elements, right, this was our matrix B. In matrix B, we had A, and B. This was B. And for B square, we have AB here, right? This is our matrix B square. And in matrix B, we have these three elements A, and B. So 1, 1, 1, that will take care of this identity, that will be taken care by this identity matrix. Now, element in first row, second column, that is 48. So therefore, one of the equations will be 48 equals to, and in second row, first row, second column, in B square we have 0, and in matrix B we have N. So N into B, and that plus this multiplied by 0. So N into B, and here we have A. So this means 48 is nothing but N into A. This we are getting by comparing the element in first row, second column of A raised to N from here given matrix and from this right hand side. So this is one equation. Similarly, element in second row, third column, this is 96. And on right hand side, the element in second row, third column, that will be N into B. So this is another equation, right? N into A is 48, N into B, this is 96. And finally, element in first row, third column, this is 2160. And from right hand side, we'll get N into B, that means N into A, right? N into matrix B, and in matrix B, we have A here. And that multiplied by N into N minus 1 by 2, B square. And for B square, the corresponding element is AB. So these are the three equations that we have, right? One equation, NA is 48, other equation NB is 48, 96, and then this is the third equation. Now after this, it is not difficult to solve these three equations. You can substitute NA as 48. In place of N into B, you can write 96, and then you can solve these three equations. So once you solve these three equations, you will find that the value of A, this will be 4. And because we need this value, N plus A plus B, so I'll directly write the answer after this. I mean, the calculation is not difficult. Just substitute these values, and then you can get the answer. NA is 48, and then NA 48, and in place of B, you can write 96 by N. So then first you will get the value of N. N will be 12. Substitute that value of N in first equation, then you will get A as 4, and then substitute that value N again in second equation, you will get B as 8. So N plus A plus B, that will be 12 plus 4 plus 8. So 12 plus 12, that is 24. So that is the correct answer for this problem. In this problem, the important concept was to write this matrix uh, A as I plus B, where I is identity matrix, and then this matrix B is 0 on diagonal, 0 below the diagonal, and then these three entries A and B. So once you calculate B square, you will get AB, and B cube will become null matrix. And the moment you have null matrix, any higher power of that matrix, because if BQ is null matrix, B raised to 4 is nothing but B cube into B. B raised to 5 will be B cube into B square. So all of these matrices will become null matrix. And because I and B, these two are commutative matrix, so here you can apply that binomial expansion. So finally, A raised to N, that was I plus N into B, N into N minus 1 by 2 into B square. By comparing the corresponding elements, we got these three equations. And after solving this equation, you will get N 12, A and B as 4 and 8. And therefore, N plus A plus B, that will be 24. And that is the correct answer for this problem.